we are back to another day solving LeetCode problems. I believe we are in the last problem for the arrays and hashing part of the roadmap. It's the longest consecutive sequence, and that is the problem of today. Amazon, Microsoft, Google question, Adobe, Spotify, and yeah, very excited to finally stick to this and finish it. I don't know if you're like me, hopefully not, but I have all this list of problems. You can go and check the other videos where I just start solving random problems in different lists, and then I get bored of that list and jump into another list. And at the end of the day, we're solving LeetCode problems, but it would be nice if I could stick to one list. But anyways, we're at the end of arrays and hashing here, and longest consecutive sequence says as follows. Given an unsorted array of integer nums, unsorted, return the length of the longest consecutive elements sequence. Return the length of the longest consecutive elements sequence. Okay. You must write an algorithm that runs in constant time, or big of n, and that's it. We got an array of 100, 4, 200, 1, 3, and 2, 4. The longest consecutive element sequence is 1, 2, 3, 4. Therefore, the length is 4. This is going to be tricky, but that's it. Wow, that's like a short little, very ambiguous description. Anyways, 47% of people have solved this question on, I believe this is the first attempt try. 252 people online trying to study this problem right now. And yeah, pretty cool, pretty cool. Let's see. So I think in this problem we're gonna need to, before I go crazy into trying to think it's data structure, it's a thing of timing too. Like I feel like I see the problem, I have to solve it right away. You start getting used to solving these problems and wanting to solve it because you think that's what you're gonna face in an interview. But sometimes it's good too, especially for these videos, to digest the problem so you can look at it and really see how everything's working. And for me, even look back into these videos and realize things I was doing. So obviously, let me not jump the constraints. The length of the array, we have to keep that in mind. But anyways, it's asking for the constant, it's asking for constant time. So even though these would be like a smaller array, let's say, I don't know, 10 to the 2 maybe, or even like if we're dealing with a 15 elements array, that we could brute force that solution and it would be really heavy on the machine. They're asking for a specific runtime or time complexity, which pretty much boxes our solution into getting creative, because we don't have a sorted array, okay? And we have to find elements that count up to certain consecutive sequence, okay? So let's see how we're gonna solve this. I found a cool tool that I can finally use without having my computer to hog so much RAM. And I can right here, I got all the other software running and this is not freezing. So I can finally explain concepts as I work the problems, because before that it was just a pain to, try to draw something here and my computer would try like froze or whatever. But here we are definitely going for the win. JavaScript for the win. I don't know what you want to say about JavaScript, but look at this. This is written in JavaScript and it works. It simply works. Sometimes that's what you need. And how do I know this is on JavaScript? Well, first I'm running it on my browser, but second I went to delete something and look at here, JavaScript void. So you can track these elements and pretty much, call that function basically that I imagine is what puts the stop into the previous element you were selecting. So you can select the pointer here, put a void in the pointer, and then come and select the pen. So pretty cool, pretty cool. I just like that there's a tool now that I could use for that. So basically the problem is asking us to find the length of the longest sequence of consecutive numbers in an unsorted array. Okay, so a sequence of numbers, we could say it's considered consecutive if every number follows the previous one, so without any gaps. So let's say we have a 1, we have a 2, a 3, a 4. That's a sequence of length 4, right? So in our array, since we have an unsorted array, let's say this sequence could be represented like this, and we would not know, how long is the sequence unless we, let's say, create a process here. That's the algorithm we're going to work on. we cannot afford sorting the array. We already know that because it's asking for constant time. And to sort the array, the minimum we're gonna do is big O of n log n. Okay, that's gonna be at least in Python and most arrays. I think this is pretty much standard on all major sorting algorithms, n log n. Obviously there are different running times, but for the ones that matter, this is the running time. So we cannot afford doing that. So what would be the next step? And I'm gonna take a pause here because I think my camera went off again. This is the second time it goes on my PD. So let me just take a quick look here real quick. And it did. Why is it doing that? Why? Are you sure we should close? No, I don't want to close the application. I need my camera to work. Are we back? Yes, we are back. Sorry about that. I mean, it's been happening. I'm using all these Canon software that really sucks. Jesus, Canon software is just terrible. And I mean, this is just the camera I have. I bought it years ago, and that's what I'm using to record. But their software, I mean, they really need good engineers like us, right, to build this software. Throw that plug in there. But anyways, we're back. We're back on. So as I was saying, we cannot afford sorting the array, right? This is going to be our input array. Let's call these num. And, you know, we're going to try to find a subsequence similar like this. So following numbers, obviously with no gaps in between. So like, let's say if we have a 6 here, that wouldn't be part of this sequence because there's a gap in here, right? 5 is not present, so 6 cannot be part of this sequence or subsequence. But anyways, that's another hint there. Let's move on into what we need. We might need to use a famous data structure to solve this problem. And, you know, when you are thinking about patterns or data structure patterns, it's important to remember, you know, the main ones. I think I just realized is the fact that some of these lists will give you the topic you're on, right? Let's say we would have to try to solve this problem from the get-go, but we're coming from a list like this when we, you know, arrays and hashing. Okay, so we know we're manipulating arrays. We know we're dealing with hash tables and whatnot. That's a little bit of, you know, comfort we have in that sense. But here, let's think about data structure that we could use in Python to solve this problem. That's supposed to say Python there, but you know, we're getting used to the writing here. We could use a hash set, or in Python, a popular or famous set. Okay, and that set would basically remove any duplicates in case we have a duplicate. Let's say this is our input array here. We could always have another one here, or another 2. So if that would be the case, we don't want to have duplicates at the time of checking, because that's what the set is going to serve us for, to check if there's any number in this sequence, right? I think that's a conservative approach. I think we could say that we could do that, right? We can create a set to remove the duplicates, in this case, let's say 1. And from there, we can iterate over our main list right here and check for existence into our set, okay? This is becoming a little cramped. I'm gonna basically restart that. But yeah, a set could be a great data structure to help us convert that array into a set, or maybe backwards, maybe like this, where we're gonna take that input array, make it a set, and then check into existence. A good thing to know here is at the time of converting that set into, let's say s is going to be equal to set, and that's going to be the input array nums. Okay, this is constant time. No, this is linear time. I mean, converting these elements, it's going to be linear time, so big O of n, and that is the maximum we can afford for this problem, right? But the benefit of set, and this is why set would be great here, is the fact that it's constant time to check for existence. So once I convert all my numbers from my input array into a set to check if the elements are into that set, it would be only constant time. So as long as we keep our checks under that time constraint, we are good to go to solve the problem. So let's proceed with the steps to solve the problem. Okay, so the first step was building the set. Now we know that with the set, and I'm using this as an example, this is going to be our original array, 4, 1, 3, 2, and 6. We're going to convert that into a set, just like that. And let's say our output set, it's going to be this right here. Now the second step we need to do here is create over our original array. array nums, right? And we're going to iterate over that array in that same order. Let's assume we can iterate over that array in the same order we got it right here. Now we have two conditions for every element. And let's say we're going to call that element X, okay? We're going to iterate over element X, which is going to be the element we're going to be iterating over. The first thing we need to check is, we have the set with the original numbers from here, no duplicates. The first thing we need to check is if X minus 1 is in the set, meaning if there's a number, if the number before X exists already in the sequence. Why do we want to do that? Well, basically, let's say we have a 5. We're iterating over X equals 5 in this case, right? If 5 minus 1 equals 4, it's in the set, which it is right here. That means that 5 could potentially be part of a sequence that has started already, okay? So we want 5 to be part of that sequence so we can continue enlarging that sequence. Now, if 5 is not, if 5 minus 1 is not part of that sequence, and I'm going to use another example for that with the same inputs we have. Let's say we have here, I don't know, 8. Let's do 8, okay? So if 8 minus 1 equals 7, if 7 is not part of the sequence right here, then 7 could potentially be the starter of a new sequence, okay? And those are basically the two things that X is going to serve us for. It's either check if the number before X it's in the sequence, because if it is, then X, it's part of that sequence, and we want X to be, as part of that sequence, to enlarge that sequence and make it as long as possible, which is what the problem is asking for. Or if it's not, let's say X minus 1 is not in the sequence, then X could potentially be the starting point of a new sequence. So those are two things we have to keep track, okay? And this works because we need a way to count potential sequence. Once we have a starting point, we have two things that we have to look for, If 4 it's either part of the sequence of it's 4, or if 4 is the starting point of that sequence. That's pretty much all we need to cover, because it's, if 4 is not part of that sequence, let's say 4 it's 100 in this case, then we know it's either going to start a new sequence at 101, or we just simply discard that number because we don't need it for our sequence, because we're trying to make this the longest as possible. So that would be the second step. Check for the two conditions of X. Let's move on into the next step. Great, so we built the set from the nums array, okay? Now we're gonna iterate over the sequence to detect if X minus 1 is not in the set, or if X minus 1 is in the set. X being the number we're iterating over, as I mentioned, okay? So if X could be the start of a new sequence, okay? So we have 4. X equals to 4 in this case. If X minus 1, which is equal to 3, it's in the set, then X minus 1, which is equal to 3, it's in the set, then that means that X is not the starting of a sequence, okay? And particularly here, we want to look for the sequence starter, okay? The reason we're checking for these conditions is because we need X to be a sequence starter, because we need to count how long the sequence is. And once we find the starting point of that sequence, we can count upwards, okay? Or in ascending order. So X minus 1 at this point, it's in the set, meaning 4 did not start any sequence. 4 could be part of a sequence. So we move into the next one, which is 1. X equals 1 minus 1 equals 0. If 0 is in the set, which is not, meaning 1 could be a sequence starter. And that's what we want here. Now we know that 1 could be our sequence starter, and we can start counting how many numbers after 1 are present in our set. How are we going to do that? Well, we have to assume a couple things here, but first we're going to create another variable named y, and y is going to be equal, since we know that 1 it's a sequence starter, we want to check if y, which is going to be equal to x plus 1, is present in the set. So starting from y, which is x plus 1, we're going to start counting in ascending order to find the length of that sequence, meaning we started at 1 because 0 is not in the sequence. So we started at 1. We're going to say if y, which is equal to 2 in this case, is in the set, y is going to be plus equal to 1. So we're going to keep counting upwards, keep counting in ascending order. And basically this right here is going to be our counter that is going to count the length of that sequence. We're going to probably also need an answer array, or not necessarily an array, because I don't believe we need to return an array. No, we just need to return an integer. So basically we're just going to have an answer variable that it's going to contain the maximum length, okay, of that subsequence or that continuous sequence or consecutive sequence is the term. But here our answer array, basically we're going to initiate that probably at the beginning, but this y plus y, which is equal to x plus 1, it's what's going to be our counter that is going to be updating that answer array. And I believe that would be our third step. Basically find the sequence starter, assume that x plus 1 is in the set, and while x plus 1 keeps iterating over and finding itself in the sequence, meaning, and let me clean these up a little more to explain that part there. We just know a couple of those scrabbles I had on the screen. So x, as long as y is in the set, we're going to keep incrementing our y here, right? So in our first iteration, x plus 1, which is going to be equal to 2, is present in the set. So this becomes 2 now, okay? 2 plus 1 equals 3. That's also present in the array, okay? So we keep iterating. 3 plus 1 equals 4. That's also present in the array, and so forth. So basically, the length of this sequence, it's equal to 4, which we can prove just by simply looking at this, right? But actually, that's going to be stored. The best way to prove that, it's going to be storing it in a variable that it's going to contain the maximum number of that sequence that we find down here. Okay, so I believe that would be our third step. So let's continue with the next and probably final step to solve this problem. So our next step would be update the sequence length, right? Now we know that it started at x and ended at y. So we could say, you know, if it started at, let's say 1 and ended 4 minus 1, it's going to be the length of our new sequence. And this is just x, which was the starting point where we knew we had the starting of a sequence, and then y, which became y plus 1 plus 1 plus 1 all the way up till we couldn't find another part of the sequence, or until we hit a gap in the sequence right here. So, you know, y minus x is going to be the length of our sequence, and that's going to go and update our answer array that we could here use perfectly. We could use here the max function in Python just to get, you know, the max number out of our sequence. So we're probably going to have sequence length here. We're going to have a couple variables that we could play here. So that's going to be our next step. We build the set, get the duplicates, find the sequence, detect if x was part of the sequence. Once we find the starting point of a sequence, we create an extension of the sequence, basically counting all the way up. We update that because we hit a point into here in a while loop where we know that's gonna hit an end or find a gap. So once we hit that, we know that's the end of our sequence. The way we're gonna update that is basically saying y minus x, or the ending point minus the starting point. It's gonna give us our length of that particular sequence, and we proceed to update our answer array. Okay, let's go ahead and finish this problem with our last step. And then finally, we just have to return the results, because after iterating over all the elements, we found our max sequence in this particular example, which was 4, the max length of our sequence. That updated our array, and all we have to do is return that. I hope that was clear enough. If you have some questions, just please let me know. I try to explain this problem as I study too, So if you have questions or if you want to make any declarations, I'm very open to it. This is a learning experience, and this has been my #1 goal since day one. I really appreciate your support and your time. So if you like this video, please smash that like button and subscribe if you want to know more, or if you want to just support the journey. So thanks so much for that. Let's go ahead and jump into our solution code. Alright guys, let's jump into our code and let's go ahead and solve these problems. So the first thing we said we're going to do is build a set or convert our nums array into a set, and we're going to do this as follows. We're going to say num set is going to be equal to a set, and here we're just going to simply convert our nums input array into a set, and that's how we're going to do that. And the next step we need to do here is count our longest sequence, or have our counting, let's say, variable, right? In this case, I'm just going to name that longest, and at this point it's going to be equal to 0. Okay, perfect. We created our set and we created our longest sequence counter starting at 0. So the next thing we need to do here is iterate over our set and see if X is part of the set already. So we're going to keep that short. We're going to say for n in our num set. Now we need to check if n-1, and I'm going to put these in parentheses here just to remember this is an operation we're doing. If n-1, we can check in constant time in our set. So we're going to say if n-1 is not in our set, it's not in our num set, then we can say that the length of our sequence is going to be equal to 1. Why? Then because if the previous number is not in our set, then that means that n is the starting of that sequence. So the length of our sequence automatically became 1 because we started at n. Okay, and then here we could say while n plus the length of that sequence is present in the array. And again, guys, you're gonna probably see me make some mistakes as I type. Remember, I'm trying out my Kinesis keyword. I said that days ago. If you haven't watched the video, go and take a look at it. But yeah, I'm trying a new keyword, and you know, these fingers are getting tricky. But anyways, while the length of our sequence plus our number, well, that is in our num set, the length keeps increasing. So here I'm gonna say plus equal 1, and at this point right here, again, let's say n was equal to 1. If 0, it's not in the num set, 1 could be the starting point of the sequence. So starting from 1 plus 1, meaning 2, is in the set, then that sequence is going to keep increasing. Meaning, you know, we started at 1, 2 is in the set, so we have a sequence there. Now we're going to check for 3. 3 is in the sequence, we're going to continue. 4 is in the sequence, and so forth. You get the gist. But from 1 all the way up to 4, we have a sequence of length 4. So we are counting using basically a counting variable here to keep track of that length, and a variable that checks a previous position in that array. Okay, so we check if we are the starting point, and if we are the starting point, we start adding up from there. So at this point here, we know that once our while loop hits a point where there's a gap in our sequence, let's say we hit a 6, right, and 5 is not in the sequence, we know our sequence ended at 4, then we need to update our longest up here. Okay, so we're going to get out of the while loop and say that our longest is going to be equal, and here we could use max to keep track of that length we just calculated and the longest, because at some point, you know, longest in the first iteration is going to be equal to 0. Well, let's say we find a sequence of length 4, that longest is going to become 4. But then we find another sequence of length 6. We have to pick which one is the maximum sequence from either that length, counting all the way up, or the longest sequence we had previously, because we can also find a sequence that's smaller than that one and we don't want to update it. So we always grab the maximum, because that's what the problem is asking for when it says longest. Okay, so till this point, I think we're pretty much done. We just need to get out of this loop, and here, let me get a space here, and here we can say return longest, and I believe these would solve the problem, right? We created our set, removing duplicates and basically allowing us to check for existence, right, in constant time. Yes, this operation right here is probably going to take, or not probably, very likely is going to take big O of n, okay? And that's going to be the limit. According to the problem description, that is the maximum we can afford. But also, this loop right here is going to be big O of n, okay? So, and I'm just going to do that there for just for the sake of commenting. This is not something, you know, just to explain the problem, but this loop right here is going to also be big O of n. You know, here we're checking, that's constant time. Here we're checking, that's constant time. Here we're just updating variables, that's constant time. And here we're just updating a variable, constant time. Now, the max iteration here, the max operator is only checking 2 elements, okay? I believe this operation right here is not bigger than big O of n. It shouldn't be. So at this point, I think we're pretty much very solid. We kept our constraint. Now, you know, we had to create a new data structure, which means our space complexity, this is all time complexity, our space complexity at this point is probably going to be big O of n as well. But also, we didn't have anything in the problem saying we can use big O of n for our space complexity. So, you know, even though space is big O of n too, because we had to create a set, you know, just as large as nums, but without the duplicates. And we had, you know, in the back end, as that set iterates over nums, removing those duplicates, constant time. So from there, I think we can go ahead and submit our problem. First, I'm gonna just run just to make sure we passed the first test cases, so we are ready to submit. Let's see how we do. I think we did pretty good. Let's see. Fantastic. Great. Okay, that solves our problem for today. 51 milliseconds, 60%. You know, these things are kind of crazy here. I found the other day, let me click in here. Take a look at this. Take a look at this. Check this out. And the way I knew this was crazy is because I see, you know, how many submissions you have here, and you have the bulk of submissions here. But look at this, guys. These guys are manipulating the read part of the test, and they write the time, the display runtime, they write it at 0. So all their problems, even though, look at this, there's no way these algorithm would take 0 time, especially in Python. There's nothing in Python taking 0 time. 2 + 2 in Python would take, you know, 50 milliseconds. I don't know, I'm exaggerating, but they're writing that, and I believe, I mean, I don't care. If that makes you happy, be happy with that. I really don't care. But I just think it's funny. You're inserting this thing in your code, probably just to, I don't know, win rankings or something in the boards. Totally, you know, I don't know what that helps them, because I mean, recruiters at some point can look at that. I don't know if they're looking at your code. I don't know what they're looking at, but this is just, come on, man. Like, and you don't even know who they are. Like, I don't think I can find that person. They're doing this for stupid reasons, but that's not the reason of this video. It's just funny. I found that people always look into hacking, but that's technology. So you gotta love the good parts and the bad parts. Guys, thanks so much for following today. I appreciate your time. Smash that like button and subscribe. Support the journey as I go through this hard industry of tech and get me a job in tech. I continue to make videos for you guys. I continue to learn so much. Leave something in the comments. Let me know what you think if you made it to this far in this video. Thank you, and I'll see you in the next one.